precious and valuable collaboration with our guests and industry sponsor, Fred Caserta with Pleiadian System Corporation. I'm not going to tell much about the project, but I want you to know that these two projects, the one that we couldn't unfortunately present previously and this one, each one of them used a real world set of software that is being implemented by an enterprise or a company, software development company, for Pleiadian systems. So they are actually using a real and enterprise level solution in order for them to integrate or contribute to expanding features and capabilities of that project. And with that being said, I want to let you imagine the level of complexity that means for the students in terms of learning a new environment, mastering a new infrastructure and code, and master it enough in order for you to integrate your contribution. So if you want to know more about it, I'm going to let Ryan and Lester tell you about it. Guys?
Hello, so this is HELLSMOKE. I'm Ryan Gibbons, and this is Lester Berrios. And first, we'd just like to thank Fred and Pleiadian Systems for this fantastic opportunity that we were able to have. And so, our project context, it's a little different than everyone's, except for the group that was supposed to go before us. But Pleiadian was developing this fire and smoke simulation to help train firefighters. And there was three key aspects that they were looking to improve. The performance of the simulation, because after several minutes, the whole simulation would kind of start chugging along, and especially for VR, that causes all sorts of problems, as you don't want people in VR to start stuttering, because that just causes, motion sickness, and it's just not good. And then there's an improper behavior of the fire and smoke, as we'll demonstrate in a little bit. And there needs to be a more balanced utilization between the CPU and the GPU to help improve that performance.
So Pleiadian's application is called HELLSMOKE, which is a VR simulation, as Ryan just mentioned, and it uses a unique particle system in Unity to create fires around the environment and smoke, so that when a student is using the VR and interacting with the environment, then they would need to put out the fire using items such as a water hose or a fire extinguisher, and the students be able to communicate with each other to complete different tasks and missions within the VR simulation. And it uses elements just as Unity physics, objects and properties in Unity created to help the project be united together.
So our project formulation, the domain of the project is that fluid and dynamic particle systems are quite computationally expensive, and VR requires consistent frame rates for users to use it comfortably for long periods of time. So our problem ended up being we needed to maintain higher frame rates for longer periods of time for a more viable product. Unity's built-in particle system, we're going to hear the word particle system tons of times, so be ready for that. Kind of lacks any in-depth tools to change individual particles at a moment's notice during runtime. And the built-in particles are running on the CPU, which takes away vital resources for the rest of the simulation to be able to run.
So potential solutions that we were looking into was to improve cleaning systems integrated algorithm for the particle system. We also thought about implementing a new particle system such as the VFX graph or NVIDIA Flex or NVIDIA Flow. And we also wanted to provide cleaning systems with a cloud-based option to help the simulation run on a web browser using Microsoft Azure or Amazon Web Services such as AWS.
Our proposed solution, and the one we ended up going with, was for the fire and smoke behavior, we decided to use Visual Effect Graph, which is Unity's newer particle system that runs on the universal render pipeline. And the main draw that brought us to this is the ability to manipulate individual particles specifically, and that can happen over time or over the lifespan of that individual particle, and the entire particle system is rendered and maintained by the GPU, which we'll get to, but it caused some problems later on. But it was a big selling point for us to focus on the performance of the simulation.
And we chose Azure Web App because it was the most viable option to host the project on cloud-based. So it eliminates the need to use high-performing computers as a dedicated computer. So you can log in using a Chrome or a Firefox and using the link, and then you can access the simulation through your web browser.
So our objectives were to improve particle quality and, of the fire and smoke, improving the behavior of those effects, host a version of the HELLSMOKE system on a cloud-based alternative, to just have that as an option, as a possible future endeavor to increase the ability for Plebeian to sell this to a wider audience and balance the utilization of CPU and GPU resources to increase the performance.
So our methodology is a microservice platform because it uses multiple different services such as Unity 3D, VR technology, the VFX graph, and a bunch of other such as Azure Web Service. So it uses all these different services to help the application run and have the availability to give it to other clients for industries, universities, and academies.
So these are the results that we ended up having, and they're split into several groups. So this first bracket here is one computer, and then the second bracket and the third bracket are all separate computers, because we wanted to run on a wide variety of machines. So this first one here does not have a dedicated GPU, and the bars on the left are, from left to right is the CPU's minimum usage, the CPU's maximum usage, the GPU's minimum usage, and the GPU's maximum usage. And even comparing it to the computers that use the dedicated GPUs, the performance or the utilization of the hardware between their minimum and maximums during a 10-minute test between the two different particle systems really balanced out between the two. In a lot of cases, either they both came down or one of the utilizations went up while the CPU came down, but that overall they were able to come to more of a balanced level between the two instead of relying solely on one and being handicapped by that. So we're going to get into, this is the current particle system using the built-in Unity particles.
So as you see, you'll see there'll be a fire started, and then the smoke will spawn in, and then you'll see in the bottom like small particles of fire, and then as it gets as it runs, the fire will spread around the environment, and the smoke will also build so that the students will be able to see and then manipulate the fire using like water or extinguisher, and then it'll grow throughout the environment.
One of the downsides that we noticed while working with the system was the smoke kind of appears to just fade into the environment instead of flowing how we expect smoke to flow. So that would be, it starts where the fire is and travels up to the highest point it can go, and then starts working its way out from there, and then when it can't go out, it comes down. So this is the particle system using the virtual effect graph. And as we can see, the fire would be started in the same location, and there's a central point where the fire was started, and then the smoke actually travels up and out, and then over time it will begin to burrow its way down. And we're able to do, a lot of the performance we were able to get was from a technique we used to, you only use one particle system to control all the smoke particles, and that was a big part of the VFX graph, allowing us to manipulate individual particles by using a 2D texture and individual pixels being set to RGB values, and then those RGB values being converted to XYZ position data. Whereas in the old system, a new game object had to be spawned every single time smoke needed to spawn in a new location, which during runtime is quite expensive task to do.
And this is just the Azure Web GL build. Because I'm time, I'll show it real quickly. But as you can see, the build is on Firefox, and it's on like the URL link, and then you can actually access it, and it actually runs pretty well. So I'm gonna fast forward here. So it basically, it runs the exact same, it still uses the original one, but you can still have the fire be placed down and then spread, and then the smoke also will also spread around. So you can see this fire there, and then the smoke starts to come and then spread around the environment. So it runs fairly well on the WebGL. So the only impacts, the difference between WebGL is that it does not support microphone input. On the original project, it does use microphones to interact with students so that they can communicate with each other and form a team to finish their objectives. So that's one thing that we'll be doing in the future is like integrating microphone input with different assets to override the WebGL.
Great. Guys, unfortunately we have some time constraints and we still have a couple of projects we wanna have the opportunity to explore. So I'm gonna ask you a few questions, but I'm gonna also hand it over to your stakeholder. I don't know if I should consider Fred part of the team because of the affiliation with the project, or part of the evaluation team as someone who saw you, involved in this project for many months now, and probably can witness on the exchange, on the quality of the work, on the skills that you have shown. So I'm gonna get back to Fred pretty soon. But the question that I have for you is, what were the main challenges that you faced throughout this project?
For me, one of the main challenges was the WebGL build, because a lot of things weren't compatible with WebGL. There are limitations to it. For example, when I was first have the project, I had to convert a lot of things from the original project in order to build that first WebGL to export it. And then I had issues with uploading that to the Azure Web Service because of their integrated multiplayer asset was not fully compatible, and I found assets online that were actually updated, so managed to make compatible and updated the version on Unity 2. So that was a big issue because I kept getting errors. I would fix one error, then another one would pop up, and then it would just cycle through like that. So that was one big challenge I had. And also researching online, there wasn't many documentation out there to help me with this. A lot of it was self-learning, figuring out, testing different things, and just trial and error. So it helped me realize that a lot of this is done in the industry, trial and error, in order to get a fully polished prototype working for a company.
Right. I would have to say understanding how, because a big focus for us was increasing performance. So understanding how the technique was actually implemented, of using colors to store position data and then converting back into XYZ values that I can actually use to place particles in each location instead of having to spawn a new game object every time. That took quite a while to understand how that would even function.
Okay. My following question is about team organization. So you decided, or you opted for this industry-based senior project. You are just the two of you. You insisted that you wanted to stay just the two of you in order to take that responsibility. And now we are 2 semesters after. Do you regret that decision? And what motivated that decision first?
No, not at all. A lot of it came, Lester and I have been working together on many projects, and it started in last year during physics class. We just happened to be placed together. So we've been working together for, at that point, a whole year. So we knew we worked really well together. And it was a lot of, it's not that we didn't trust bringing people in, it was that we knew we worked wonderfully together. And that adjustment period of having to adjust how we already work together, add another person in, it did, at least to me, it didn't seem like a smart use of time working on the project, trying to adjust how we've established that we work together already.
Okay. My following question is, I remember you guys had a quite interesting feedback that you shared with me. Fred was not with us, about the first time you were in touch with the actual code of the product. And just for the records, so that everyone here is aware, these 2 students, as well as the 5 other students that worked on the drone for situational awareness improvement platform, which both of them used the platform or the framework that Pleiadians own and develops. They had to go through, an NDA form signature in order to commit to the the full respect of the intellectual property, and all what you are seeing here has been verified before being communicated to you. So explain to me the experience that you had signing that document, knowing that you are committed to a privacy and respect of that intellectual property owned by Pleiadian, and how was your interaction with that code that is coming from a team of developers who have been working for months on that project versus the assignments and the small code that you have been manipulating in the classroom? How was the transition? How was the interaction?
For me, it was exciting and at the same time overwhelming too, because I remember when this was first mentioned to us, I was excited about the whole thing, and then signing the NDA was like, I remember I was so excited about it because I felt like an actual business person. When I remember seeing the code in the project, it was overwhelming because I'd never seen something so complex. But it also helped me learn how to deal with overwhelming things and how to approach them in the proper way. I remember talking to Ryan, and we were like both like surprised to see all of this in front of us too, because we've never seen anything like as complex as this. And it's nice to see it because this is going to be in the industry, in the real world. So it was nice for us to get an early look at all of this, and for me it was an amazing experience doing all this. I had a bunch of fun. I loved working on this. It was amazing. I hope to work on this in the future too.
I totally agree. I was very excited, and then we finally got our hands on the code, and you're like, okay, this is the script that I need to modify, and you open it, and it's calling things somewhere else. You're like, okay, let me open up that one, and then that one's calling things from somewhere else, and then all of a sudden you have like half the scripts open from the entire project, and you're sitting there and you're like, oh.
Sorry about that, fellas.
That's not your fault. It's necessary. But I remember like a month in, we were like, we talked about it, and we're like, we are never gonna finish this. We're screwed. But it ended up all working out. quite a few late nights, but totally worth it every step of the way. So thank you for that.
Oh yeah, you're welcome. Thank you. Thank you.
I don't know if what you want to statement to question. The floor is yours.
Well, I would just thank you guys again. Thank the University of New Haven, and you, Professor, and all the participants in this, because it's for us to be a industry partner with UNH. It's critical. It's vital. It's an exciting project. Obviously, it poses challenges. But we're really kind of taking something and we're doing something very innovative in an industry like the first responder industry, the fire service. This software is actually being utilized by one of the top 5 fire schools in the country. So it just came up in conversation several times today that what we hope to do within the next 3 to 6 months is introduce what we're doing here to the fire science program, right, at the Dr. Henry Lee College of Criminal Justice and Forensic Science, so to let the fire science students themselves utilize it, right, and get feedback. And hopefully between the computer science and engineering and the fire science program, it'll be a collective endeavor, and the fire service will benefit from it firsthand.
Absolutely.
So thank you again. Huge opportunity.
Thank you very much.